In section 2.5, we're going to look at percent and how they relate to fractions and decimals and other ways of writing number. We're going to just look at some visual examples of percent, and then we're going to take a look at a new model that I'd like to show you, in addition to the models that are discussed in the textbook. So first of all, let's make some sense of percent. We're asked here to write the shaded region in terms of percent of the rectangle, the whole rectangle. So what we have is, we have a region, part of which is shaded. So if the whole region is 100%, then we can start identifying which sections of the region are worth how many percent. Well, it looks like the region was cut into 5 parts, right? So if there are 5 parts, then this should be 20%, and 20%, and 20%, and 20%. The last of the 20% is actually cut in half, so this looks like 10%. And then that remaining 10%, there's only half of it is shaded. So if we actually add all of this up, then the total is going to be 95% is shaded. Let's take a look at number 2. The whole rectangle is 100%. It's partitioned into 4 equal areas, so each of which will have to be 25%, as will this last area, but only a fifth of that is shaded, so that would be 5%. So the total shaded region would be 80%. See, so we're actually playing with a lot of visual information and trying to figure out how that can be used to figure out how many percent are shaded. So let's try number 4. If this whole region is 100%, I see again partitioning into quarters, 25% each. So if this is 25%, and half of that is shaded, then 12.5% presumably is shaded in this region. And let's take a look at 5. Again, this whole region is 100%. Well, this is 50%, it's half of it. And if we look at half of half, that's 25. And another half of that much is 12.5%. So shaded, we have 87.5%. I will leave number 3 for you to figure out. Now, as I promised, we're going to be looking at another model for percent, and I'm going to be solving most of these problems using that model so that we can get used to how that model appears in different scenarios and problem solving. So the textbook looks at the area model here and the percent table, and you certainly should focus on those and make sure you read the section 2.5 if you're a little rusty. But I'm going to present the percent thermometer method. And percent thermometer is just like what it sounds. If you remember thermometers, in the good days, one side is labeled in Celsius and the other side in Fahrenheit, for example. So it's possible that even though our level of dyed liquid here is going to be the same, one side might say 32 Fahrenheit and the other might say 0 Celsius. So we could be reading off different things on either side of that thermometer. But the temperature outside or inside, hopefully outside at 32 Fahrenheit, is actually the same. It's just 2 different readings. So we're going to be using the same idea for our percent thermometer modeling percentages, but on the one side, we're going to be using percent, and on the other side, some kind of number. So for example, if we're going to calculate 95% of 80,000, then we're going to say, well, great, we have 80,000, and we want 95% of that. So 80,000, if that's what we have, that's going to be our 100%, and we want to figure out what 95% of 80,000 is. Lots of ways we can do this, but one of these ways, for example, is to say, all right, well, I know that 40,000 is 50%. It's half. Well, if 40,000 is 50%, I could also figure out how much 5% is, and that's 4,000. So that was helpful because I know that to get from 100% to 95%, I need to subtract 5%. And if I do that on this number line, I'm going to be subtracting 4,000. So what I'm finally going to be getting is 76,000. There are lots of other ways, as I've said. You can drop down to 10% at 8,000 and from there figure out your 5,000, or any number of other ways. This is a very creative process, and there's a large number of ways in which it can be done. So let's look at a percent thermometer for number 2. Calculate 15% of 6,500. So we have 6,500 and we want 15% of that. Now, what is 6,500? Well, if that's our whole, then that is our 100%, and we want 15%. So let's see if we can have some fun here. So if I know that 100% is 6,500, I can figure out what 10% is, right? It's just a tenth of that, 650. But I need another 5%. I need to get to here, so I need to add another 5%. So let's see what 5% is. If 10% is 650, then 5% is going to be 325. And then we should be able to find that the 15% is going to be 975, because I added 325 here, which is 5%. For the next few problems, I'm just going to set up the percent thermometer with you, and I will then ask you to find the values on your own. So calculate 7% tax on a $25 purchase by first finding 1%. So one side is going to be percent for us, and the other side is going to be dollars, because we're looking at the cost of the whole purchase. We have $25 purchase, and we want to calculate 7% tax. We want to know how much tax we're going to be spending. In America, tax is charged on top of the purchase price, so you can expect to pay a little bit more than $25. This is not the case in most of the rest of the world. But if $25 is our 100%, we can find 7%, and there are lots of ways to do this, but they're asking us by first finding 1%. Well, 1% is 100th of that, so 1% is 25 cents. So then what is going to be 7% is 7 of those. So on top of the $25, we'll pay $1.75. I will set up the number 4 for you, but ask you to do it yourself. So 60% of 810. So we have a percentage and a number. 810 is our 100%, and we want to know what 60% is. And what it's asking us to do is first calculate half of 810. And I will let you do that on your own. Find another way to calculate 60% of 810, so you can go back and create a second method for that. And then I'm also going to leave you with number 6. Use the percent table to calculate 55% of 180. Let's look at some applications and take this percent thermometer for a bit of a ride and see how it does. The problems here ask you to make a math drawing, use percent table, but I'm actually going to just limit myself to the percent thermometers, and you can get the practice with math drawings and percent tables from the textbook. Let's take a look. First of all, we have Lenny, who's received 6 boxes of paper, which is 30% of the paper he ordered. So we have a percentage and we have boxes. So he received 6 boxes, which is 30%. So this statement is actually telling us he only received part of the order, which is actually only 6 boxes or 30% of the order. What we want is how many boxes did he actually order, so we're looking for what was that full order, what was that 100%. So we can do a few things to solve this. Well, I could say if 30% was 6 boxes, then 10% is going to be 2 boxes, a third of that. And if 10% is 2 boxes, then 100% is going to be 20 boxes. So there's going to be a total of 20 boxes that he ordered. Let's look at number 2. Ms. Jones paid $2.10 in tax on an item she purchased. So there's a percent and the cost. She paid $2.10 in tax, and the tax was 7%. So the 7% of the item was $2.10. And the question is, what price of the item, not including tax, did she pay? So she is then looking for how much the item was. Let's see if there are ways that we can figure this out. We could always go through 1. So 1%. And that's going to be 30 cents. So it's a seventh. So then 100% is going to be $30. You could have gone to 70% and figured out that that's $21. And then make that division a little bit easier. Go down to 10% as well. Lots of different ways to do this. Let's look at number 3. Green Valley, the average daily rainfall is typically 5/8 of an inch. Last year, the average daily rainfall in Green Valley was only 3/8 of an inch. What percent of the typical average daily rainfall fell last year in Green Valley? So it seems like we have a percent question, and then we have inches. So if the average daily rainfall is 5/8 and it only rained 3/8, 5/8 of an inch versus 3/8 of an inch. Right, so the average daily value is 5/8 and it only rained 3/8. Then our average daily value is what we're comparing to, and that's our 100%. So if 5/8 is 100%, then how many percent is 3/8? We could go down to 1/8. So a fifth of that is 20%. And then 3 1/8 is going to be 60%. Just as an idea, I'd like to ask you to draw this. Same kind of thermometer, but one side will be percent and the other side, the units, would be 1/8 of an inch. And see what happens when you do that. See if you can solve the problem using 1/8 of an inch on the other number line, or on the other side of the thermometer. Let's look at number 4. If a third of a cup serving of cheese provides your full daily value of calcium, then what percentage of your daily value of calcium is provided by 3/4 cups of cheese? So percent of your daily value of calcium. Third of the cup of cheese provides you with the full daily value. Third of a cup of cheese provides you with the daily value. Then what percentage of your daily value of calcium is provided by 3/4 cups of cheese? Oops, we're going to be eating more than our daily value. So let's give us some space. So a third of the cup is 100% of daily value, and we want to know how much of the daily value would we have if we ate 3/4. So how would you be able to figure that out? We can go back to some ideas that we had in fractions before, and somehow it seems like we might have to resort to going through 12ths. If a third is 100%, then a 12th is 1/4 of that. So it's 25%, because there are 4 12ths in a third. Now, how many 12ths are in 3/4? 9 12ths. If 25% is 1/12, then 9 12ths is going to be 225%. Okay, so let's take a look at a couple of other problems. These are a little bit more challenging. Even though they said use a math drawing and a percent table, we're going to continue using our percent thermometer. And in this question, there are 30 blue marbles in a bag, which is 40% of the marbles. How many marbles are in the bag? So we have percent marbles. 40% is 30 marbles. And the question is how many marbles are in the bag. Those are blue, and then there's other colors as well. And I will leave the rest of this one for you to think about. Number 2, Andrew ran 40% as far as Marcy. How far did Marcy run as a percentage of Andrew? So we have two sides of the thermometer, both of which are percent, but one is percent of Andrew and one is percent of Marcy. Now, who ran more? Andrew ran 40% as far as Marcy. So if this is Marcy, this would be Andrew. Andrew ran 40% of Marcy. So if we said that Andrew ran 40, then Marcy would have run 100. How far did Marcy run as a percentage of Andrew? Well, if we're doing a percentage of Andrew, then he would be at 100%, and we want to know what Marcy ran at. And the setup of this problem was quite challenging because we're using percentages on both sides of the thermometer. But the actual mathematical calculation is going to be quite similar, so I'm going to leave that for you. Let's set up number 3 as well. And then I'll leave number 4 for you to complete. In a terrarium, there are 10% more female bugs than male bugs. If there are 8 more female bugs than male bugs, then how many bugs are in terrarium? So there's percent, there's bugs. 10% more female bugs than male bugs. So there are female bugs and there are male bugs. And the difference is 10%. 10% of what? More females than males. So the males are 100% and the females then are 110%. Now, if there are 8 more females than males, then this distance is 8 bugs. Another way that we can write this is we can say that 10% is 8 bugs. Can we figure out any of the other values? Well, if 10% is 8 bugs, what's 100%? 80 bugs and 88 female bugs. So the question is, how many bugs are there in terrarium? And I will leave the final answer to you, and I will leave number 4 to you as well.